And we're live. Thank you for joining us for another Facebook Live. We are recording this and we're going to repost it on YouTube later so that we have an archive of it and it's easier to get to for those of us that aren't on Facebook very often. Thank you for coming. I can see that there's 12 people in the room. At least one of them is here in the building. So if you're here, I don't know who you are. So can you please just say, I'm here in the comments, and that way I can see your name and I can recognize you. I'm looking over here. This is my my monitor over here that I can see the comments as they come in. And I would really appreciate it if you would say hello so that I know that there are people actually in the room. There's Tom Goudreau. Is that how you say your name, Tom? If I butchered it, please forgive me. I really appreciate it, Tom. You're the first person that raised their hand. There's Brian Barbalas, Sydney Baker. Very cool. Very cool. I appreciate you coming. We are answering RockSim questions today. If you have a question, you can also go ahead and put that in the comments. Gregory King is here. Tim, looking forward to today's topic. Ralph Strausser says, hi there. Hi there, Ralph. Glad that you're here. We had one previous question from Joe. Joe's here. Good. So I'm going to be answering Joe's question because he answered a question just prior to us going live. Ronald Zacher is here. Thank you, Ronald. So Joe's question was about asymmetric rockets. So that's what today's topic is going to be, about asymmetric rockets. What's an asymmetric rocket? So if you take a rocket like this, this is the Apogee vapor rocket, and so this is not an asymmetric rocket because kind of you look at it from any angle, it's about the same any way around. But if you get an asymmetric rocket like this one here, this is I think it's the Alien Interceptor. Nope, the UFO Invader from Semrock. I just grabbed an asymmetric rocket from our showroom. So now this rocket is an asymmetric rocket. So if you look at it from one side, it looks completely different from the other side. So that's an asymmetric rocket. And how does RockSim handle that? And how do you know if the rocket's going to fly straight when you launch it? Because on an asymmetric rocket, the direction that the wind hits it, it's going to make a difference. You know, if it hits it this way against these big fins, it's going to cause it to rotate this way. But if you're sideways on it like this and the wind's coming that same direction, there's less fin area here to cause rotation. So the direction of the wind is important on an asymmetric rocket, and that's kind of what we're going to talk about. So let me switch screens here and let's go to RockSim. So here is my desktop. If you're new to RockSim and you've never used it before, if you want to try it out, here on our desktop there's this banner that says RockSim 10 available. If you click on it, it'll take you to where there's information on how to upgrade, but right here it says free trial version. If you click on that, this is where you sign up for the free trial and you get 30 days of using RockSim. Almost all the bells and whistles. Okay, so let's go into RockSim and let's design an asymmetric rocket. Oh boy, we got somebody in here from Taiwan, and I can't read Taiwanese letters. So if you could say your name in English, I would appreciate that, if it's pronounceable in English. Okay, so asymmetric design. We can either open an existing design or we can design one ourselves. So let's go ahead and try to design one from scratch. So if you're on RockSim, up here at the top is the new button. So I'm going to start a new design and I'm just going to purge out my old one. I'm going to say no to saving that change. We're going to go here to Rocket Design Attributes tab. You always start on these tabs and you kind of work from the left side to the right. So this button is kind of hard to click on. The hot spot is kind of in the word attributes. So if you put your mouse on the attributes somewhere and try to click on that, that's when it was clicked. If you try to click somewhere else, it doesn't want to click. So you got to kind of find that hot spot. And you can see that the shading on the button changes when you're in a hot spot. So that's where it is. I'm going to call this asymmetric rocket. I don't know if I spelled that right. And we're going to use the RockSim stability equation. It's going to be a single stage rocket. And I'm going to say rocket designer. I'm going to put my name. So when you design a rocket, go ahead and, you know, take the credit for it. Can't spell my own name right. Okay, my name is Willie Yu. Thank you, Willie. Appreciate you coming all the way from Taiwan. It's really early in the morning there, I'm sure. Or is it late at night? Okay, so now we're going to go to the Design Components tab, and we're just going to select a nose cone. It doesn't matter. I'm going to look for something BT60 size. So we have a nose cone. I'm going to give it a different color because I always tell people make things a different color so that we can see them. So the color is the color tab right here. So now we have a pink or magenta nose cone in 2D, and it's orange in 3D. Click OK on there, and then we're going to add a body tube. So make sure that's highlighted and click body tube. And I'm looking for a BT60 size tube somewhere in here. Here's a BT60, and click OK. I'll make this screen a little bit bigger so you can see it. Make sure I don't cover up anything that's important right here. So I'm going to leave the length at 18 inches. I might even stretch it a little bit. So to stretch it, I'm going to just make it longer here. Longer rockets are always more stable, so we're going to say, that's why I'm going to say this is a longer one. I'm going to throw in a motor mount real quick. So I'm going to do an inside tube, and let's call it a BT20, which is 18 millimeters in diameter. So I'm selecting that from the database. Again, let's make this a little bit bigger. Make sure that you can see it over here. All the good stuff is important, is right here. This tube is shown in blue. I'm going to change the length. So first, I'm going to make it shorter, about the size of an engine mount. I'll just make it 3 inches. And I'm going to say, reference it from the base of the owning part. So now it's located 23.5 inches from the back end right here. And I'm just going to slide it all the way to the back of the rocket till it's 0. So now it's flush with the back end of the rocket. I'm going to change the color. Make it a colorful, rainbow colored rocket. Okay, so now we got an engine mount in there. Let's add some centering rings. So highlight the body tube, click on centering rings, and I'm going to cancel out of the centering ring database because RockSim has a feature to automatically calculate the known values, and that happens when you start sliding the ring backwards. So right now, here's our ring. It doesn't have any thickness, so let's give it some thickness. I'm going to call it 0.05. 0.05 is about the thickness of a typical cardstock centering ring. I'm going to change the material to paper. So here's our ring. Let's make it a different color. 2D color, it's orange. 3D color doesn't really matter until we get into 3D anyway. So I'm going to go back to the General tab and just continue sliding it back, and then watch the inside diameter change as the centering ring gets over the back end of the tube. So it will automatically adjust it for us so that we don't have to really worry about the inside diameter of that ring. So there's that one ring, and let's call it the forward centering ring so we can tell it apart, because we're going to add another one here really quick. And I'm just going to do a copy and paste. So I'm going to take my mouse, put it over the name, and do a right click on it. and it brings up this menu, and then I'm going to say copy, and then I need to paste it somewhere, so I'm going to paste it into this body tube. So again, right click and then paste, and you can see now we have two centering rings, and they're right on top of each other back here at the rocket. So I need to move one of them. So I'm going to grab this second one, double click on it to open it up. And then we're going to change the location. Actually, I should have changed this to the base of the owning part. So that if I change the length of the tube, the centering ring will stay positioned where it wants. I always make my centering rings, that aft one, about 1/2 of an inch from the end of the tube. And the reason for that is to make sure that you can get the engine mount in. So let me show you what I'm doing over here. Okay, so here's our engine mount back here. And so we have the back end of the tube. This is kind of clear. And then here is our centering ring, and it's recessed about 1/2 of an inch. So that if I put an engine hook on it, I can bend that engine hook up. So that's just one of my design tricks, is make sure that that aft centering ring is at least 1/2 of an inch away from the back end of the body tube that it goes into. Okay. We have Derek on the camera today making that adjustment for us so that we can zoom in. Appreciate that. Makes it easier for you guys to read. Willie says it's now 15 minutes after the hour of midnight on the 20th. So we're on the 19th here, so he's a day ahead of us. Really cool. Okay, so we have our aft centering ring. I just need to change the name over here. So I'll call it the aft so I can tell them apart. And I'll click OK. So now we have this design. I'm going to do a save just so that in case anything happens, I'll just put it on my desktop. I'll call it Asymmetric. Okay, so I just throw it on my desktop, so now it's saved. I do want to adjust this forward centering ring. It's just bugging me that it's located from the aft or the front of the owning part. So I'll make it from the base. And the reason we do that is so that if we come back to this body tube and adjust the length, now everything, see, I'm making it shorter, and that whole engine mount is just tracking with the length of the tube so that I don't have to go back to it later and make adjustments to it. The other thing that I need to do on this body tube is to make this an engine mount. So I'm clicking that, and this is a motor mount, and it's an 18mm size, and I'm going to call this the motor mount tube. Okay, so now I'm kind of adjusted. So now let's start adding fins and making an asymmetric rocket. So I'm going to go to the body tube because that's where I'm going to attach them. And I'm going to add a fin. And for the first fin, I'm just going to make it a trapezoid fin. And we're just going to adjust the size down here by just changing the slider bars. The semi-span is probably the one I'll adjust first. I'm going to make this one fairly small. My root cord length. Again, I need to make it sure that it's adjusted from the base of the owning part. And I'm going to put the fins all the way at the back. So I'm going to type in 0 for the location and hit the tab key. And you can see that on my screen it jumped back to the back end of the tube. Make sure the material is set to a real material. This is a common mistake people forget, is they don't select the material. Okay, I'm going to change the color on these fins, so I'll make them blue and make them this color here. And go back to the general tab. I just want to check everything. Right now I have 3 fins. I'm going to change the count to 2 fins. So now we have 2 fins here. And I don't know if you noticed that when I made that change, but watch that center of pressure location. So I go back to 3 fins, and now the rocket is stable. You can see that right here. Our CG is in front of the CP. So in front means it's a lower number, and you can see the margin here. What the margin means is the distance between these two icons, the center of gravity and the center of pressure, and it's divided by the body tube diameter. So if you take this length divided by that diameter, the units drop out, and it's now just a dimensionless number, and it's 2.54, which means that this distance is 2.54 times the diameter. And when we design in rocketry, we want to make sure that number is at least 1. So that's 1 caliber of stability, which is, the caliber is the diameter. So it's at least 1 body tube diameter ahead. The center of gravity is ahead of the center of pressure. But when we change it to 2 fins, now look what happens. The center of pressure jumps all the way to the front. Because what RockSim is doing is it's looking at it at the center of pressure location from multiple angles. And now it's looking on from that side view angle. And you can kind of figure out that it's going to be unstable in one wind direction, but stable in another. So what we can do, and we can see that, we're going to click OK here. Let's just look at the rocket in 3D so you can kind of get a better perspective here. So I'm going to detach this window here and then make it larger. And then I can move the rocket around. And if you can't see the fins, hold down your shift key and then click and drag, and then you can see the rocket better. You can also go to this button right here. This is the camera controller. If you click on the camera controller, it brings up this screen, and you can recenter the rocket right in the middle of the screen. That way, if you start rotating it around or moving it around, it will rotate in the middle of the screen. So you can see we have just 2 fins on this rocket. So now I'm going to reattach this bar here. I'm going to do that by clicking it and holding and dragging. You can see as I drag it down here to the bottom, and I let go, it will reattach. If it doesn't reattach for you, you probably have an older version you want to upgrade. You go here to the View menu, and you click on Restore Window Default, and that will put your windows back in this order right here. So right now, just to let you know, I am using RockSim version 10.1 build 179, and I think the current build that most users are using is build 173. This is a bug fix version that I'm using. I'm kind of beta testing as we're going along here. We want to get this out as quickly as possible because it has a lot of fixes in it that have annoyed people. One of them is dual deployment. The other big one is on occasion it will crash on you. So we want those crash bugs are the ones that we want to fix as quickly as possible. So expect a release out very soon, within the next few days, because we don't want people to suffer a crash, because that's kind of like the worst bug of all. Okay, so now what I want to do is go to the preferences of RockSim. On the Mac, it's under the RockSim menu, and I believe on Windows it will be under the File menu. If it's not under File, it will be under the Help. But in the preferences, you're going to see this screen right here, and I want to click on this 2D drawing tab right here. On this tab, there's a checkbox that says Stability Graph Overlay, and I want to check that. And also, let's check the angle grid. And then I'm going to click OK. And now if I go back to the base view, you're going to get this drawing here. Let me detach this again to make this bigger for you. So this is looking at the back of the rocket. Now, I made the fin colors the wrong color because it's hard to see. I made them light blue. I should have made it a dark color. But here is one fin coming down, and then here is another fin coming up. So if we look at the rocket, if the wind is coming from this direction, anywhere from over here or from down here, this rocket would be unstable because we have this red indicator line right here. But if the wind is coming from this direction off the side, and this looks like 1, 2, 3, 4, 5, 6, 7, 8. So 90 divided by 8 is what? 15 degrees? Somewhere in there. Derek's got his calculator and he's going to tell me. It looks like somewhere in 11.25. Thank you, Derek. So if the wind is coming from anywhere past 11.25 degrees, this is in the green zone. The green zone means good. It would be stable. It's kind of like looking at the rocket. You know, this is straight on, so this would be 90. So if it came in from the side, but not from directly from the side, but from the side, it would be stable. But RockSim doesn't want us designing unstable rockets, so it's going to say unstable. So that's kind of what this this grid view does. Most people don't use it because most people are designing symmetrical rockets. But when you're going asymmetrical, you want to look at this view right here. Ideally, we don't want any red at all, because if the wind hits the rocket from any direction where the red is, we're going to be unstable. So we don't want that to happen. Let me reattach this window here and go to the side view. So we need to add additional fins on this rocket. So I'm going to add another fin set here to the body tube, and we're going to do regular type fins. Regular fins, cancel out of the database, move this screen over so you can see it. Again, what it's doing is it puts a generic fin right here. Let me change the color. Let's make it a darker color. Make it a nice purple. And it made, if I look over here, I got 3 fins, and this time let's change it back to 2 fins. Again, my rocket is still unstable, and it's going to be unstable until we change the position of those fins. So I'm going to go to the radial position tab right here, and the radial position is adjusting the fin orientation on the tube. So if I look at it from the rear view right here, you'll see where those fins are. And it's easier to see right here because my fins are nice and dark. And if I take that radial angle and I start adjusting it, now you can see that it's green all the way around. It's more stable if the wind is coming from this direction than if the wind is coming from that direction. You can see that. You can see the curvature here. So if the green line starts curving in, and if it actually gets in front of this line right here, this circle right here, that's kind of like the trigger point where it's going to be unstable. So right here, I can zoom. Let me zoom in. So to zoom in, use your mouse, do a right click on the screen, then select zoom in from the menu. And I'll zoom in some more. So you can see, I can see just right here, right next to the fin, is a red line, and we don't want any red lines. So I can still see one red line right here, and at this point everything is in the green. So at this point, if I actually click OK, let me go back to the 3D view here so you can see what this rocket looks like. If you look from at the back end, You see, this is actually a stable rocket. Now, I wouldn't fly it like this. To me, it's still on that hairy edge, but RockSim thinks it's stable. But you can continue adjusting it, and I'm going to go all the way out to 90 degrees and hit my tab, and it'll be 90 degrees out. You can see now it looks more like a traditional rocket. Let's go back to the 2D view. It's zoomed in, so I'm going to zoom back to the original. So right click and then hit zoom original. You can see now this fin, you can see it's just a line right here because we're looking straight at the edge of it. I'm going to go back to the database or general tab. I'm going to just start adjusting that fin. Now, if you want to look at it from a perspective, you have to flip it over, and that's what, right now we're looking at it from the side view, and I want to click on it and look from the top view. So I'm just flipping the rocket 90 degrees. You can see now my fins are nice and big, and I can take this. I wanted to make them even bigger, which is why I came over here. Make them more like wings. And I'm going to say from the base of the owning part, and I'm going to, oops, make them bigger, and then I'm going to change my location. I'm going to slide them up here. You can see my center of pressure is getting close to that center of gravity, but I'm still okay. I'm probably okay until I put a rocket motor in it. Let's leave it right there. Okay, so I'm back to the 2D view. Let's put a rocket motor in it and see what happens. So to get a rocket motor, you click on Prepare for Launch. Right here we have the base view of the rocket, and we have one motor mount. I'm going to choose the engine, and let's choose an Estes C6. Let's go with a 5-second delay. Click OK to accept it. So now it threw it back in here. And I'm going to say OK. I'm not launching yet. I'm just going to say OK because I want to see if the center of gravity shifted. And sure enough, if I zoom in, my center of gravity is behind the center of pressure. And if I come over here to this side, you can see the rocket is unstable. So we don't want to have an unstable rocket. Eric Raker has joined us, and he's from Guam, and he is also tomorrow. I hope tomorrow's a good day. We got 18 people in here. If you're just joining us, say hello so that I can recognize you, and so I know who's here. Otherwise, I have no idea who's here. So as you look through the comments, people are raising their hand and saying, "I'm here." Yeah, raise your hand and say, "Yeah, I'm here." Say, "You can start now," because I'm here. There's a couple of comments in here. Joe Noble says, probably fin count of 2. Brian says, once we design a rocket in RockSim, is there a parts list so that we can order parts from Apogee? Brian, I'll answer that question, and the answer is yes. Tom says, when you have off-center body tubes or scoops, such as the Snarky or Firefox, what is the best parent component to the anchor to? Okay, we'll try to get to that one, Tom. Craig is here. Say hi, Craig. Glenn Ahrens is here. Hi, Glenn. And Eric Raker is here. So hello. So Brian, I'm going to answer your question real quick because that's an easy one. So if you go to the rocket menu here at the top of the screen, and you just drop down, here's the parts list. So this gives you all the parts that are in the parts so far. I didn't select too many parts from the database. I did select the motor mount, and this is an Apogee part. So it gives you a part number here of 10086, and if you want to order that, you highlight it, you do a copy. I'm going to just go to the Apogee website real quick, and you can paste that number right here in the box, in the search box, and it pops it right up. There's a feature on our website that not too many people know about, and if you know the part numbers, and if you want to order everything real quick, you go to shop, and then you go to over here on the right side, do a rapid ordering. And if you click on rapid ordering, you can just put in the part number right here, paste in the part number and hit the quantity. You can see it brings up the body tube so you can order it really quick, and then down here at the bottom you can add everything to the cart really quick. So let's get back to asymmetric fins. So that answers Brian's question. So what happens if we were to launch this rocket right now? It says it's unstable. So let's go ahead and launch it. I want to just check what thing. Oh, we don't have a parachute in there. So cancel out of that. Let's add a parachute. Our parachute button is over here on the side. I'm just going to throw in an 18-inch parachute, an Apogee parachute. Here it is at the front. I'm going to change the location. I'm going to slide it back. Our rocket is still unstable. Sometimes just adding the parachute will make it stable. Oops, I changed the diameter. 24-inch. I just wanted to move the location. Everything else looks okay. Maybe we'll change the color. Make it purple again. Today is a purple rocket day. And click OK. Now let's go back to the flight events. We should have a parachute, max ejection delay, simulation controls. We'll leave alone. Starting state, we're on a 36-inch launch rod. We didn't put a launch lug on here, but we can still launch it without the launch lug. We'll assume we're just coming out of a launch tower, so we don't need a lug for today. Launch conditions, we've got a wind of 8 miles an hour coming from the left side of the screen, blowing to the right. Yeah, I like that. So let's go ahead and click flight profile and see what happens. So we did the rocket launch. Make sure we can see it on the screen here. So down here at the bottom is our rocket. We're going to go ahead and click the launch button here. And the rocket takes off. Ooh, and it did go unstable. So RockSim did not like it. And you can see that it's flopping all around. You know, it's doing cartwheels as it's going across the sky, which is a bad thing. This black line right here is called our weather cocking cone. And we want the apogee point, the highest point in the flight, to stay within that cone. And you can see we're already out of the cone, and the rocket is, that's probably about the apogee right there. But we're outside of the cone. So basically the rocket it's gone unstable, and we don't like it. And then it falls back down to the ground. And it gets back down to the ground before even the parachute comes out. Sometimes the rocket can go stable as the motor burns, because basically you got weight in the back, and as you're burning propellant, the center of gravity is shifting forward, and the rocket can go stable again. So sometimes we can try to get that to happen. I can do that by maybe sometimes moving the parachute. If I change the location of the parachute. So now we're on the hairy edge of stability there. And let's launch it one more time. Flight profile. Let's see if we can get it to go stable. Nope. Oh, there it goes. Did you see that? It's unstable, and all of a sudden it becomes stable there. And this is really bad. You can see the rocket is now stable, and it's going in a projectile fashion. And when it hits the ground, you don't want to be standing over there, obviously. This is why we always want to make sure that when we launch, that static stability is stable. So here we're coming off launch, we're cartwheeling over and over, and all of a sudden at this point, it's getting stable and more stable and more stable, and then, and now the motor actually burned out. But just imagine if that was a long burn motor. It could cause some damage. So that's what we want to avoid. And again, our apogee point is way outside the weather cocking cone. which is a cool rocket. So let's save this rocket and let's go answer another question. So hopefully, Joe, I answered your question. And if there's another question, go ahead and put it in the comments field. Let's do Tom's question. And his question is, when you have off-center body tubes or scoops, such as on the Snarky or Firefox, what is the best parent component to anchor the respective part to? If the engine mount is what connects the aft and forward body tubes, does it matter which tube is shown as holding the motor mount? How do we differentiate between a tube that blocks flow, where a tube may allow flow, more like a radial tube fin? Okay, so as if I understand this correctly, Tom, you're asking if we have something like a Snarky and we're putting the motor inside the tube where airflow can go through it. Ooh, that's a really good question. This is a learning opportunity here. So let me go here. Let's open up the Snarky rocket. Let's see if I can find the Snarky real quick. Snarky rocket. Save my changes. I'm going to say yes. Okay, so here's the Snarky rocket. Let's go to the website here. And so you can see an actual picture for those of you that don't know what the Snarky looks like. So I just type in Snarky in the search bar and it pops up here. And it gives us an image, and you just click on that image and we got a big view of the rocket. So what Tom is asking is, okay, we're going to add a scoop right here, and then we're going to put a motor inside of it. Is that correct, Tom? Because that's what I'm going to do. I'm going to try to do. Okay, so let me go back here to the screen. So here's the Snarky. Right now, let me go to 3D and detach this screen so you can see it. I'm going to rotate it around so you can see there's the scoop on the bottom of this. You can see it from the back as well. RockSim doesn't allow us to remove the part of the tube that intersects inside. So we would account for that basically by doing a defined mass on the body tube. So this body tube here on the outside, it has a weight, but what we would do is do a mass override specifically on that tube to remove part of the weight that's on the inside. I keep hitting this rocket over here, but that's not what I wanted to do. Okay, so let me reattach this window. Let's go look at that base view because I just saw something pop up, and so radially all the way around that we've shown before. If we look at it from this radial view, since this is an asymmetric rocket, our center of pressure is behind the center of gravity by that distance. And what does that distance mean? Well, you have to see it from either the side view or the top view. It's basically what it's saying is this rocket's stable, so you don't have to worry about it. So now let's go to the components. Okay, so we have the main fuselage, and then we have an inlet tube right here. So now this inlet tube, I can tell from the components tree that it's not a tube fin. It's actually an inside tube, just because of the icon right here. That's an inside tube icon. And so if I look at this inlet tube right here, and if I come to the screen here, if I look at it from the rear view, let me turn all this stuff off because it's a little hard to see. So I'm going to cancel out of this. Save changes, no. So I'm going to go back here to the preferences. And I'm going to turn off the stability graph overlay. Okay, so now if I go back to the base view, all that stuff doesn't show up. And now I'm going to edit the inlet tube here. And let me change the color of it so we can see it better. So today's purple day, so we'll go make it purple. And let's zoom in on it. So you can see this is the tube that we're editing here. And right now, it's offset because there's a radial distance here. See, if I adjust the radial distance, I can move that tube around. And so if we want to put a motor into it, so Tom, that's one of the questions. One of the questions is, what tube do we attach it to? So right now, this inlet tube is attached to the main fuselage tube. So that ideally answers the question. I'd always attach it to the main tube because it's easy to find that way. Now, if we want to put a motor mount in it, it would be easy to put a motor mount into this tube because I can highlight the tube and then click on inside tube, and let's put a 24 millimeter motor mount tube into this. You can see right here it dropped it in. Let me go to the side view so we can see it from the side view. You can see this is that motor mount tube that we added. Change the length. So it's roughly 3 inches long. And change it to the base of the owning part. Slide it back to the, oops, yeah, changing the length. I didn't want to change the length. I want to change the location. Grab the wrong slider bar. And I'm going to go all the way back here. I'm going to say this is a motor mount tube. And we're going to call this the motor mount tube inside the duct tube so that we can tell it apart. I'm going to give it a different color here so we can see it also in 3D. Okay, so we added that tube. Let's go back here to the side view. So we have this purple tube down here is our inlet tube, and then we have a tube inside of that, which is another motor mount tube. So this is actually now a cluster rocket. Let's look at it in 3D. So you can see what it looks like. Let's go here to recenter the camera and see if we can rotate it around. Oops, too far. Too far. Zoom in, pitch it up a little bit so you can see we have two motor mounts. We have this outside one here, and then the one inside here. We don't have any centering rings, but adding centering rings would be pretty easy. So I'll take that inlet tube, hit centering ring, and I'll just add it real quick like we did before, just sliding it back. Holy cow, look at that. It put it on the inside of there. You see that? We can fix that. We'll just uncheck this right here and then change that inside diameter. I believe that's a BT70. So I can go to the database. I'm going to choose from the database. I want a 24 to a BT70. So 24 to 56 should be a BT70. Yep, I was right. I'll zoom in on it so you can see it. So there's that centering ring. And again, I'll just adjust the position. It's paper, centering ring, color is orange. I like that. And I'll just change the name. Forward duct centering ring. I'm going to copy that like we did before. Oops, copy. Then paste. Then here's the two rings. And I'm going to edit that second one. And I'm going to change the location. Ooh, I guess from the front of the part. Again, I'm just looking from like about a 1/2 of an inch is what I usually like. So I'm just going to type in 1/2 of an inch and then hit tab, and it put it back here, and click OK. All right, so now we got 2 motor mount tubes in there. Let's see what happens when we launch. I think what's going to happen, let's see if it's stable. So our center of pressure, let's zoom to the original. Center of pressure is still back here. Center of gravity is up here. And this purple tube, this big one right here, it still assumes that it's an inside tube, so it's not adding to the stability of the rocket. So if I change this purple tube at all, it's not going to affect the stability except for the center of gravity. Where'd that inlet tube go? So I can kind of show you that. So watch the center of pressure right here as I change the length. You know, I can change that length to anything I want, and it's not affecting the center of pressure location at all. I don't remember what it was, but I'll just leave it right there. Now, if it was an outside tube, then it would, like if it was a ringtail or a tube fin, then it would affect the center of pressure location. If it's stable with this configuration as it is right now, where it's an inside tube, if I changed it to an outside tube, it's going to be even more stable. So I am not worried about this rocket being unstable in this configuration using an inside tube. Let's go ahead and quickly launch it and see what happens. Again, you saw we have 2 engine mounts. This first one is the main one, and then the second one was the new one, because we can see we changed the name. Let me cancel out of that. Cancel. And then just expand this right here so we can see the full name of it, so we know, you know, which tube we're assigning to. Let's throw in a motor here. Let's go to an Estes D12. Let's make it 7 seconds delay and click OK. You can see it added it to the main tube, and if we want to quickly add it to the second tube, we'll just click Load All. What Load All does is it says, okay, this tube that we've highlighted, let's load that motor into any other tube that is the same diameter. So the same diameter is 24 millimeters. So we'll just click Load All. So now we have 2 rocket motors in there. Starting state still 36 inches, same conditions as before, 8-mile-an-hour wind. Let's launch it and see what happens. I'm pretty sure this is going to be nice and straight. Click Launch. Rocket takes off, goes straight. You know, goes straight up. And then once the parachutes pop out, I'm going to just accelerate it by grabbing the slider bar here just to see where it lands. So that was a good trajectory. I can tell the question you might have is what happens if I take one motor out? Will the rocket go unstable? So let's try it. So we're going to click on this one. Let's take out this one right here. Clear that one. So now there's nothing in it. And let's click Flight Profile again, see if it's stable. Let's launch it again. Yep, it's still stable. The reason is when you have motors on the outside like we do now. So on this rocket, if we go to the aft view or the 3D, we're only showing one motor. RockSim is assuming that the thrust of the motor is on the thrust center line of the rocket. In real life, is that true? No. But RockSim thinks it is. That's one of the limitations of RockSim because it's a 3 degree of freedom simulator. Now, if I save this rocket, I'm going to do a file save as. I'm going to throw it on my desktop. We'll call it modified snarky. Oops. And click save. So through here on my desktop. Now I'm going to open up this design in RockSim Pro because I like to show this off because this is where 6 degrees of freedom makes a difference. So this is RockSim Pro. This is our beta version. It's not out yet, and if you ask us when is it going to be available, the question is soon. We're still working on the final cleanup of it, so it's not available yet, but I can show you what it's going to look like. So I'm going to open that modified snarky design. So there it is on my desktop, and it opens it up, and again you can see it's the same design. I'm going to go to the flight simulations tab. So we just ran this last simulation with the D12, just one D12. I'm going to say load those engines. And you can do this in RockSim as well. You know, this is the quick way to load engines. You just highlight the simulation you want to see, click load engines. It's throwing up an error message, but I'll just okay that. And I'll go back to prepare for launch. See, it loaded it back here. You see in the back, it did load the motor. Let's try to do the same type of simulation as we did. 36-inch launch guide, launch straight up, straight up. Let's look at our wind. So we have an 8-mile-an-hour wind, and this wind is coming from the west. This is our launch location, which is important in RockSim Pro, because this is going to tell us a little bit more, gives us more information when we run a simulation. I believe this is, I'm not sure where this is, 70 degrees. We'll launch it and find out. So I'll just click Flight Profile. It takes a little bit longer. Oh, I keep forgetting I have uncertainties going on right here. I can tell right away that it went unstable because I can look at my maximum altitude. It did not like one engine hanging off the side. So this is a three-dimensional view of the rocket. Let me zoom back out so we can kind of see where we're launching here. Oh, I know where this is. This is the Great Meadow launch site in Virginia where the TARC launches are. This tiny little red dot right here is where our launch pad is. There's our rocket. And if we click launch, you can see it didn't like something. Yeah, it didn't like that at all. So anyway, that's RockSim Pro. Usually they're a lot more fun because if they go higher than that, they can get unstable and do really crazy things. So I'll just leave that. I want to, because I saw another question that came in. So hopefully, Tom, that answered your question. If it didn't, go ahead and ping me again. Dignant Joshi, and I think he is in India because he's a regular here. Thanks for showing up again. How do I calculate optimum weight of a model rocket? I ask this question because lots of time I'm experiencing that the software show that the stable but actually will be unstable flight. Optimal weight and stability are two different things. So if you're getting an unstable flight, Dignant, what I think is happening is your rocket is unstable when you're launching it. But if you want to go to optimal mass, let's open up, I had a recent design that I had. The spec. Okay, so this is the rocket I had on the screen when we first started. This is a good one to use for doing optimal mass. There was a bug in version 10.1. It was actually in all versions prior to the one that I'm showing right here on the screen, because this is a bug that we are fixing that will be in the next release. So I'll show you how you're going to do it. And I kind of did this question, it was probably maybe like the first or second Facebook Live that we did. But first we need to load a rocket motor. And the other thing that we need to do is to make sure that nothing is going to vary during the flight. So one thing that can vary is the mass, and particularly the the coefficient of drag, because the coefficient of drag is not a static number. It can change wildly. It will change with the speed of the rocket. So as the rocket goes faster, the coefficient of drag is actually changing. And if the rocket starts oscillating, the coefficient of drag is going to change. So I want to use a fixed coefficient of drag when I do optimal mass. So I want to uncheck this box, and now it's going to use these values. I'm just going to assume that these values are correct for right now. And then I want to choose an engine. So I'm going to choose an A3. My only option is 4 seconds. I can tell you right now, 4 seconds is not going to be a long enough delay. And for my booster stage, I got to highlight the booster stage. Choose an engine, an A10-0, and let's do a quick launch and see what this looks like just by itself. So here's our rocket down here on the screen. When we launch it, rocket takes off. You can see the booster stage right here separated and is falling away. The rocket's going up to the top, and right here, see, the rocket is still moving upwards when the streamer popped out. So that's what I'm telling you, is 4 seconds is not long enough. This rocket could go higher if we had a longer delay. Unfortunately, Estes doesn't make a longer delay in the A3, so that's what we're limited to. But what I'm going to do is I'm going to go back here and I'm going to make it a longer delay. I'm going to force it to be a longer delay. So where it says 4 seconds, I'm going to choose custom, and I'm going to let's make it a 7-second delay, and then I'll use that. Same flight profile, same conditions. Rocket takes off, and now it comes over the top before the streamer comes out. Now, is that okay when you actually launch it? The answer is probably yes, because to measure the altitude, you're going to use an altimeter, and the altimeter, it'll go over the top. It'll capture that peak altitude, and the rocket starts coming down. It still remembers the peak altitude, and then the streamer comes out. And so ideally, this is kind of like getting into dual deployment, where you want to deploy your streamer at a low altitude so that the rocket doesn't drift as far. So if I would have chose a longer delay, it would have popped open right about here and then landed closer to the pad, and I wouldn't have to go so far. So using a long delay when you're using an altimeter to do a flight is the right thing to do. So I'm going to say cancel right now. So now we got our engines loaded, and we've already set a fixed coefficient of drag. When we ran that simulation on our launch conditions, remember, we have a custom speed where the low wind speed and the high wind speed are the same. This makes a fixed wind speed, because if it's not a custom speed range, what happens is if you select like very windy, you can see that the wind speed is going to vary between low and high during the flight, and we don't want that. We either want no wind or a custom speed range where both values are the same. So I'm going to change both of them back to 8. And click OK, and I'll just launch it one more time. I should get the same values every time. So using that longer delay, we got a few more feet out of it. So now let's go up to simulation. Oops, I clicked the wrong button. Simulation, and we want to go to predict optimal mass. So I'm going to select that, and it brings up this screen. And I want both of these buttons checked. By default, they're unchecked, but I was playing with optimum mass this morning just to verify that it works. So it's going to calculate it automatically, and it's going to generate graph data for me. So I'll start the simulations, and it quickly runs the simulations. And it says that the optimal mass right here should be, for the sustainer, it should be 10 grams, and I'm actually at 12 grams. So if I plot the graph, I will see an optimal mass curve. Let me bring this over here so you can see it. So here's our altitude, and our optimal mass here is at that 10 gram location. Now in the older versions, there's a bug in the software and this line is going to look jagged, but we have a fix for it and it's going to be released in a couple of days. As you can tell, I'm using it and it works fine. So if it works correctly, you'll get this nice smooth curve and you can see that optimal mass. And the nice thing about looking at this curve is you can tell what would happen if your optimal mass is not, or if your mass of your rocket is not at that optimal. So right now it's set, our current mass is at 12 grams. So if I go down here to 12 grams and I come up, you can see that I'm only going to lose, this is 863 feet, 864 feet. I'm only going to lose less than a foot of altitude. So the question is, do you need to be at optimal mass? And I would say for this particular rocket, it doesn't matter that much. So if I have extra mass to play with, what would I do with it? And what I would do with it, that extra mass, is I would paint the rocket. By painting the rocket, you're going to make it smoother and your coefficient of drag is going to go down. And so you're going to go higher. And then the second thing, if I still had extra mass to spare, I would put in bigger fillets on the fin. Makes the fin stronger, and it's actually going to lower your drag because there's less interference drag on those fins. So that's what I would do with my extra weight. Let's run this simulation again. Let's change the coefficient of drag. Let's say we painted the rocket and now our coefficient of drag is lower. So now it's 0.65. And let's launch it one more time. You can see our altitude went way up. And if we do that optimum mass calculation again, now what do you think is going to happen to our optimum mass if our coefficient of drag goes down? That's a good question. Do you want to know the answer? To find the answer, just run the simulations. Just click that button again, and you can see it didn't change much. Peak altitude. Yeah, it changed. Because before our optimum mass was here at 10 grams. Now our optimum mass is like 10.6, 10.7 grams. So when the coefficient of drag came down, our optimal mass actually went up just a little bit, which is cool. That means we have more mass to play with. It's easier to make a rocket heavier than it is to make it lighter. Very good question. I'm just so happy that this worked this time. The first time, when I first ran these simulations in episode 1 or 2, which was 7 or 8 weeks ago, it didn't work. Now it's working beautiful. You can really see that optimal mass. Yeah. So I think that's all the questions, and we've gone an hour. So I do want to wrap up. Thanks everybody for coming, and thank you for raising your hand and saying I'm here, because I really like to know who's here, because we're getting some regulars every week, and it's cool to see those people, because I think they're actually the smart ones, because they're learning a lot. Every week that I run these tutorials, I'm learning a lot. So I'm sure everybody else is learning a lot too, and I'm just seeing if there's any last minute comments. All right, so we are going to end this video, and if I click on the button, it's going to end in 5, 4, 3, 2, 1,